Good day. So today I'm going to talk about chapter 12 or unit 12. In the book it's called unit, and I've put it up on Moodle as chapter, and I apologize for that. It's the same difference. Nevertheless, we're going to talk about footings today. So in the book, in Understanding Construction Drawings, 7th edition, we'll begin on page 76. So footings can come in a huge array of things, and let me find those pictures. I believe it's here. Yes, okay. So let's just start at the beginning here. 12:1, and so in this is a picture of a monolithic slab. So in a monolithic slab, the edges are thickened, and then the walls can be put up on the thickened slab. We add rebar support to that so that it will not break. It'll be a little bit more rigid and so forth. We put a vapor barrier. Generally, it's a 6 mil polyethylene vapor barrier plastic that we put down, and then we also have the gravel, the base. This is a crush and run type base that we put on there. When you're looking at the cross section of that, great, this is going to go here. We're looking at the cross section of this particular one. You can see how the gravel is shown, 4-inch gravel. We have a 6 mil vapor barrier, and then we have the rebar that's in here, and these are generally notes that talks about all of the rebar and the slab and everything at one time. So there will be one great big note on here. 2 number 8s. Okay, so that's a pretty good size rebar that they're putting in there. 8/8, so that's a 1-inch rebar, and then 6x6 1010 woven wire mesh, which is shown by this dotted line down through here. In our plans, we are shown a haunch. So here's that haunch detail, and we have 2 number 4s continuous, which is just the rebar here and here, and then we have the 6x6 1010 woven wire mesh through here. Remember that woven wire mesh and woven wire fabric, same thing. And then we have the crushed stone. Now, our architect that we're talking about here, he likes to use ROB, which stands for run of bank. So that just means that they're going to just tear the stone out, crush it up, and they're going to go with it. And that's how in the South here we call it crush and run. All right. So if you look down on the plan here, this is the foundation plan, then our haunch is shown right here, and it gives us some dimensions. So it's a total of 16 inches, and then the note tells us that it's 8 inches thick for the haunch. What is on this would be a wall. So we have a bedroom here, and we have, we have a bedroom here, this bedroom 2, and then we have this little wall right here. And that is the wall here underneath. So this is the first floor, the second floor, and here shows that wall. So let's go down here to the cross section, and you can see that the haunch is there, and it refers back to 3-1, which is that haunch detail that we just looked at. And this wall sets on it. So this wall sets here and supports the TJIs that are going across here for bedroom 2, and they all rest on this. So this is just another way of putting a footing in. So in this particular view, we're showing a different type of footing. So on our lake house here, we have what's called as a spread footing. Now the spread footing is nothing more than a larger footing than the wall. So this wall here, and let me print the screen and go over to here where I can draw. So as a rule of thumb, whatever this thickness is here, the foundation wall, in this case we are 8 inches. I don't see it anywhere. I can't. Yes, 8 or 10 inch poured concrete wall. So in this case, an 8-inch concrete wall, that thickness right there is going to be the same as this thickness here, as a rule of thumb. So here we're looking at 8, and here we're looking at 8. But then our width here is going to be 2 times that. So in this case, it's going to be 16, and it tells us right here, 8 by 16 or 10 by 20. Now, where does the 10 by 20 go? Well, remember up here where our walls, we're talking about this wall, we have an 8-inch or a 10-inch poured concrete wall. So wherever we have an 8-inch poured concrete wall, we're going to use an 8 by 16 footing. Whenever we have a 10-inch concrete wall, we're going to be using the 10 by 20. So it goes back to the rule of thumb. Whatever the thickness of this wall is, this will be the thickness of the footing and twice the thickness of the footing. There are several different ways in which we can hold the hold the walls to the footings. And in this particular example here, it shows you how that we can do that. So if we have a poured wall, then we can do our footings and we can put a keyway in here. And then when we pour the wall here, then the wet concrete, when we're pouring this wall, will seep into this little keyway here, and it will hold it in place and won't allow it to bust out. Down here, we're using dowels, and we're having a stem wall. So what's the difference in this one and this one? This one is poured separately. We pour the footing first, then we come back and do the stem wall. And then on this one here, it's one piece where everything is all poured at the same time. Here in Western North Carolina, we use concrete block most of the time. We don't do a whole lot of poured walls, poured foundation walls. So using these dowels in this way here is the preferred method that we will do it here in Western North Carolina. And if you'll look here, here is those dowels. All right, so they've poured the concrete for the footing. They've set these dowels in place. We have number 4s, number 4 by 8 inch, and they're at 3 foot on center. So when you see the word at 3 foot, that means that they're placed in the wall every 3 foot going across the footing. And like I say, in Western North Carolina, we use concrete block, and this is the preferred method. Now, where the block goes on this particular dowel, this is going to be concreted in place. We don't always concrete all of the cores in our concrete, but wherever we come to, oh great, concrete block. All right, so wherever the dowel is going to come through, we're going to pour this cell full. This one may not be poured. It depends on the backfill that is needed, and I don't see any examples, but wherever that dowel goes through the cell of the block, then this one is going to be poured for sure. sometimes we have piers. And in this case, in our lake house, we have piers that are to support this elaborate frame system in the middle of the house. So in this case, we have a 2'8" by 2'8" by 10" thick concrete footing with number 4s, with 4 number 4s going each way. Each way meaning that we're going to have them laid in this way, and we're going to have them laid in this way. So let me go back and show you how this is going to do. So we're going to have 4 number 4s placed in here in such a fashion. And then we'll have another mesh, going in here in this direction as well. And that will be within this footing here for this 3.5" steel column. Notice that this one over here is a tiny bit smaller. They're calling for a 2 foot by 2 foot by 10". Still got number 4s, 4 of them going each way in here. But because we're connected to a wall and a haunch, then we don't have to make those quite so big in this particular case. Notice that down here we still have the same size, 2'8" by 2'8". Also on this plan, you will see stepped footing. So they give you dimensions here, 6, 9, and 10, of where these steps are going to go. Now, keep in mind that you can see these also down here on the elevations. And the reason that we do this is we have a basement floor right here. And you got to remember, these plans were drawn for Albany, New York, where they have a 48" freeze line. And so these footings have to be a lot deeper here than they are in North Carolina. Most of North Carolina's frost line is at 12 inches. The mountain regions are at 18 inches. And we must be below that on here so that it does not heave. So heaving takes place, and I'll kind of give you an idea of what that looks like. Let me go to the other one. See if I can. Frozen ground spew swell. Let's see what that gives us. Frozen ground swell. That's not exactly what I wanted. Let's see. Spew. We'll try. Oops. Spew. Okay, here's what I'm looking at. All right, so these ice crystals that you see here, they can lift up an entire building. Okay, we know that when water freezes, it expands, and it has enough force to lift up a building and really mess it up. Now, the problem does not necessarily lie in the heave, but the problem lies in when it starts to melt. So let's go back over here and look at our site plan. So let's say, for instance, that this whole building was lifted up an inch altogether. So the temperatures all around here, they get to 32 degrees or below at the same time, and the whole house is lifted up 1 inch. Now, the sun comes up over in the east and warms this side of the house. This begins to thaw, and this side of the house starts to sink. As the day goes on, the sun moves over, and it gets over into the south at noon, and this portion here now is thawed out and sinking. And then as the sun moves on around and sets in the west, then this will also start to thaw out and start to resettle. Now, because this side here receive no sunlight whatsoever, it's probably still frozen, especially if the temperatures are really, really low. In the northern states, the temperatures sometimes do not get above freezing for weeks at a time. However, when we get the sunlight coming in, we can have surface temperatures much greater than the ambient temperature around us. And so we can actually have thaws here on this side of the house, and this is still stuck up in the air. So that could cause a huge, huge problem. So that is why we need to have these footings below that frost line here so that this does not heave. Well, because of the ground moves, because we have a slope on the ground, we don't need, especially in this garage here, we don't need to have all of, we don't need to have all of these going at the same height. If we take this one all the way, then over here we're going to be above the frost line. So down here we're going to have the frost line at this point, and then it can move up and move up. So when we're talking about a step footing, let me print this screen, go over here and explain some things. So when we have this footing here, we need to know a couple of things. So in North Carolina, we're going to have a minimum step footing. All right, so the horizontal step is going to be a minimum of 4 feet. All right, we can't go 2 feet, can't go 3 feet. We're going to have 4 feet minimum for our horizontal. And everybody's going to page me one time here. Text me. Let's turn that down. So on our vertical sections, where we have a step up, the maximum that we can do there is 2 feet. All right, so we have a 2 foot max height that we can rise up, but we have a 4 foot minimum on the horizontal, in which we must maintain here. Now, we could go the whole way. So if you look at some of these others, we can go a long ways before we have to drop. But we cannot just have a small piece. We cannot just drop here and have a small piece. We must have 4 feet maximum. Now, one way to look at this and remember it is block size. So let's say that we have a block in here, and I may have already explained this in some of the other ones. Whoops, lost it there. Let's try this again. So we can have, this is probably a bad picture to use, but we can have 3 block wide. My blocks are not going to be the same, please forgive me. And we're going to have 3 blocks high. So minimum 4 foot, each block is 16 inches. We're going to have 48 inches here. Blocks are 8 inches tall, so 3 times 8 is 24 inches or 2 feet on that one. So in our questions for chapter 12, there are a couple of things that you may have problem with, and I went back and I added a picture to this particular question 11 on here. So if you'll right click on that and open it up, you can see a larger one, and it will give you 1, 2, 3, 4, 5. So in these, what we're going to do is this is the east elevation, we're going to take these elevation markings, subtract the depth to the top of the footings, and then 1, 2, 3, 4, 5, and then we have you have picks in which you can go in and pick which one is the right elevation. Now, with that said, number 4 is a little screwy, but I want you to look at something here. Remember what I told you about the lift of the footing. Over here, we have, where am I at? I want to go to paint, sorry. remember what I told you, that we want to lift this a maximum of 2. However, these steps are going to step, each step is going to step an increment of 8 inches. Because we use block here, then this step here may be 8 inches, this step here may be 16 inches. But nevertheless, they're going to be in an 8-inch increment, because that is the smallest increment that we work to when we're designing a house. Now, over here, we don't have a number here, and we don't have a number here. So sometimes you have to look at other plans to figure out where they are. So if we look at this building, excuse me just a second. If we look at this building, this window and this window are the same window. We're looking at it from the south elevation and from the east elevation. So this footing is the same footing as this footing. So you can take your elevations from this side. Now this one here, number 4, again, is a little screwy. So when we go to calculate this, remember that this is an 8-inch drop. So if we're going out here and we've got something to go by here, and we subtract the 4 and the 5, 4 and the 8, then that's going to be in that line there. So this is an 8-inch drop here. You will find out that it is, and I will go ahead and give it to you, this one here is 337. Now look at this particular elevation here. It also says 337, but these are not equal. Well, the numbers tell us that it is. Okay, so maybe the draftsman that was doing this was not paying close attention and did not get these two correct, but if you do the numbers, you'll find out that the top of this one is 337. And I apologize, my nose has just been going on and on and on and on, driving me nuts. So I think that is the only question in Chapter 12 that is giving most people the problems. Most of these others you can find in the book or in the building code section of, or the design section of the building code. So use that advantage to you, and nothing else. You got Google. Also, again, you can text me, and if you have any questions, and I will try to answer them the best that I can. So for now, thank you very much, and I'll go on and do some other videos for you.